Have you ever wondered, does God exist? Have you ever looked at the world around you and thought to yourself, was this created or evolved? Are rocks really millions of years old? Did dinosaurs roam the world not too long ago? Is there evidence for a worldwide global flood? Is the Bible reliable? Is it accurate? Is it true? Join us now for this exciting episode of The Evidence. Good evening. I'm Michael Morehouse, and I will be your presenter throughout this series. I'd like to welcome you to The Evidence, an exciting seminar that answers some of life's deepest questions. Questions such as, does God exist? Is there evidence in the universe? Where did life on planet Earth come from? What is life's meaning and purpose? Is there a supernatural intelligence beyond the veil of our physical world? The Evidence looks at these big life questions through the lens of science, archaeology, history, and religion. Since we're going to be using science in this seminar, I'd like to give you a definition that we're going to be working from. Science is the study of the natural world based on facts learned through experiments and also observation. Theories are tested on experiments or observation. That's right. And this is important to know that science looks at experiments and also observation. I'll give you a sample. Here's a dog. We have a theory about dogs. Our theory goes something like this. All dogs have 4 legs. From looking at this picture, can you tell that dogs have 4 legs? No. So we have to do some observations. So we travel to Siberia. We travel to South Africa. We travel throughout North America, and we observe dogs all over the world. And in incredible discovery, we find that all dogs have 4 legs. Well, there's some rare exceptions. But almost every dog has 4 legs, except for some tragic experience. Through observation, we can test theories. And that's science. Science uses observation or experiments to test theories. Can science test whether God exists? Now, you might have your own answer for that. But I'd like to suggest tonight, yes, science can look for observable evidence in the universe to test the theory of the existence of God. And this is exactly what we're going to look at tonight. Observable evidence outside our own planet, outside our solar system, for the existence of God. We're going to take a journey through outer space and back in time to trace the evidence from our universe. We'll also be taking a look together at worldviews that every scientist has, whether he is a cosmologist like Professor Lawrence Krauss of Arizona State University, a biologist like Richard Dawkins, or a physicist like Albert Einstein. Everyone has a worldview through which they experience and interpret the world around them. And I would guess that everybody who has come this evening has come with a worldview. It's kind of like an invisible pair of glasses with which you see everything in our world and you interpret everything in our world. And there are 3 major worldviews that are out there: theism, pantheism, and atheism. Let me explain these worldviews with you. The first worldview is a theistic worldview. It looks at our entire universe and says, God created everything we see. Everything we see, hear, touch, smell, taste, and experience had a definite beginning. And that beginning was started by an eternal being, God. And only God is eternal. And the eternal God created the universe. So that's what theism states. God exists outside of our universe, which is represented by the globe there. and God alone is eternal, the universe is not eternal. That's what theism says, and you can find this theistic view in the Bible. Genesis 1:1, in the beginning, God created the heavens and the earth. The next worldview is called pantheism. Pantheism looks at our world and God as two forces that are combined, inseparable, and both are eternal. Everything you see around you is eternal. Every star, every tree, every sea urchin, and all of it contains an essence of God. God and the physical world are together, and both have existed throughout eternity. So pantheism looks at the physical world and God as both eternal. When we look at Stanford Encyclopedia of Philosophy, we find it saying, historically, the majority of pantheists have regarded the universe as what? As infinite, metaphysically perfect, necessarily existent, and eternal. The third worldview is atheism. And atheism simply means without God, and it sees the entire material universe as the only thing that has ever existed. The existence of the universe must be explained through natural means, because this is all that we have. For the supernatural does not exist. The material universe must have existed throughout eternity in some form or another. Therefore, the universe is eternal. Bertrand Russell said, the universe is just there. That's all. Theism, and I want you to notice this, theism is the only worldview that does not see the universe as eternal. Pantheism and atheism both necessarily see the universe as eternal. And so we have a test. First, Stephen Hawking saying the universe would be completely self-contained and not affected by anything outside itself. It would neither be created nor destroyed. It would just be. What place then for a creator? So here's the test. If it can be proven that the universe is eternal, then theism fails as a worldview. Because theism says that the universe is not eternal. If it can be proven, however, that the universe is not eternal, that it hasn't existed forever, then atheism and pantheism would fail as worldviews. So we're going to start with a theory. Similar to the dog with 4 legs, except our theory is the universe is eternal. And we're going to look in outer space for observable evidence for whether or not the universe is eternal. And we're going to start our search tonight with perhaps the most famous scientist to have ever walked the earth. Somebody all of us know. He's an icon of genius. His name is Albert Einstein. Now, why start with Albert Einstein? Well, because before Albert Einstein, scientists really had no way of proving scientifically or probing scientifically into the origin of the universe. There were theories, there were guesses, but nothing gave a real foundation for cosmology, which is the study of the universe and how it began, until Einstein's theory of relativity was developed. And so we're going to start with Einstein, a brilliant man with an incredible imagination. Einstein didn't think in words. He thought in pictures. Anybody here think in pictures? Maybe you're like Einstein. He always searched for words to try to describe what he saw in his mind. To give you an idea, Einstein once pictured himself traveling alongside a light beam. And he did this by taking mathematical equations and putting them into pictures in his mind, something I can't do. But an amazing thing. It was this imagination that helped him frame the most famous equation on the planet, E = mc². E equals mc squared was a new spin on what gravity really was. You remember Isaac Newton? The apple fell from the tree, and he watched that apple fall, and he said, something must be pulling that apple down. Albert Einstein completely exploded that theory. Instead of seeing gravity as something that pulls other things, gravity instead had more to do with the curvature of space. And what Einstein said is that every body of mass, your body, this building, this planet, all of it sits in space. And space is kind of like the layer of a trampoline. And when you put a heavy body, the bigger the body is that you put on the layer of trampoline, the more the trampoline curves around the edges of that body. So if you put something really big, it's going to curve all the way up and over that body. And this is what happens with space. Space curves around a massive body, which causes a contracting force that pushes down. Einstein said that this contracting force was present all over the universe. And you could think of it this way. If you had a big trampoline and you had a bowling ball and you put a bowling ball in the middle of the trampoline is going to what? It's going to sink, right? And the edges, the surface of the trampoline is going to kind of form like a bowl shape. That represents the curvature of space. Now, if you take golf balls and you roll golf balls on the trampoline, those golf balls, if you roll it straight across the trampoline, what's going to happen? Those golf balls are going to start going straight, and then they're going to follow the curve of the trampoline. And if you throw it hard enough, it's just going to curve around and around like an orbit. And this is what's happening with our planet and the sun and other planets in our solar system. They're orbiting around each other because they're following the curve of space around massive bodies. And that was the revolutionary thing that Albert Einstein came up with. That the apple didn't fall from the tree because the ground had some magnetic force that was pulling it. The apple was following the curve of space that was curving straight down. There was a problem with Einstein's theory, or with his observation. If we lived in a universe where the only force that existed was a force that pulled everything together or pulled everything in, how big would our universe be? Well, our universe would be all smashed together like a pancake. If the only force that existed in our universe was a contracting force, we'd live in a universe that had no spatial volume. But since we live in a universe that does have spatial volume, since we live in a universe that has planets and solar systems and stars and everything spinning around it, Einstein said there must be another force that is pushing everything outward. And as he worked his equations, he discovered that this force was actually stronger, slightly stronger than the force that was pulling inwards. And this bothered Einstein a great bit. Because if the expanding force is slightly stronger than the contracting force, that means everything is moving which direction? Outward. The universe is expanding. And this is why this was such a huge problem for Einstein. It's called Einstein's dilemma. Because Einstein had a philosophical worldview that did not match the equations that he was coming up with. Before 1917, this brilliant mind viewed the universe as static. Everything that you observe in the universe just hangs there and has always hung there for millions and billions and not trillions of years, but throughout eternity. So it's always just been how it always has been. Nothing has ever changed. The earth has always orbited. The stars have always moved in their paths. Everything has been just the same. But Einstein's equations upset this theory that the universe was eternal. Einstein's equations pointed to a universe that is expanding. Now, can you guess which worldview Einstein might have had if he believed in a static universe? He has two options, right? If the universe is eternal, the only two options that you have are pantheism or atheism. One of these two theories was the worldview that Albert Einstein had. And his equations conflicted with that theory. If the universe is expanding, it implies that the universe is not eternal, but has a finite beginning. I'd like to share it with you this way. If the universe is moving outward as time goes along, and every year the universe is bigger than the year before, like that. But if you go back in time, last year the universe would be closer together and smaller than the year before. And if you keep going back in time, everything would get smaller and smaller and smaller and smaller, and closer and closer and closer together. And Einstein was following this reason, this line of logic. Eventually, you come to a place where the universe can't compress anymore, and you have to have a beginning, which means if you have a beginning, the universe cannot be what? Eternal. If the universe is expanding today, there must have been a point sometime in the distant past when the expansion started. And the evidence pointed to a finite universe that had not existed from eternity in a static, timeless state. So what would Einstein do with his dilemma? On the one hand, he believed that the universe was eternal. On the other hand, his theories were pointing to a universe that had a beginning. How would Einstein resolve these conflicting forces in his mind? He had two options. He could follow the evidence, or he could reinterpret the evidence. What did Einstein choose to do? The amazing thing is Einstein actually chose to change his equations to fit his worldview. He added what is called the cosmological constant. And the cosmological constant basically was an element in his equations that balanced out the expanding and the contracting force so that everything equaled zero. Which means now his equations fits his worldview, and everything has been hanging there throughout eternity. Einstein sat back in his chair and let a big sigh of relief. I want you to know, scientists all over the globe face the same dilemma that Einstein faced with his cosmological constant, with the expanding and contracting universe, what to do with your personal viewpoints when the evidence points in the other direction. How do you reconcile that? What happens when science collides with my worldview? Well, this very thing happened a long time ago, not too long ago, with Aristotle. The great Aristotle said that the spider is an insect. And everybody knows that insects have 6 legs. And so for many, many years, nobody dared to question the great Aristotle. Because Aristotle had said it, it must be fact. And so for years, people said that spiders are insects. They have 6 legs. And who wants to pick up a spider and count the legs? Well, it wasn't until Jean-Baptiste Lamarck presented the spider as an arachnid. He caught the spider, pinned it to something, and actually counted the legs. 1, 2, 3, 4, 5, 6, 7, 8 legs. Aristotle is wrong. It wasn't until somebody was brave enough to go against what the scientists of the day were saying that you actually got a reclassification of the spider as an arachnid. Just because something is put out there by the scientific community doesn't mean it's true. In 1922, the same year that Stalin took over power in Russia, Alexander Friedman published a set of remarkable solutions to Einstein's equations. Friedman introduced the expression an expanding universe. And he went even further by saying, if you go back in time, our universe was so compressed together, was so small, that it was a point that could not be measured. And he called it an infinitesimally small point. Say that 10 times fast. You don't know how many times I've read that word trying to make sure I get it right. Infinitesimally small point. And then in 1927, oh, by the way, Albert Einstein read his mathematical equations and rejected them. Then in 1927, Georges Lemaitre, written in French, independently published his solutions to Einstein's equations. In 1931, he said the universe had to have a beginning. Again, Einstein was not convinced. Lemaitre reasoned that on its long journey to Earth, a galaxy's light, because space was moving outward and was stretching the very fabric of space, that light itself would have been stretched. And as light waves stretch, they become elongated. And when light elongates, it shifts from the blue spectrum to the red spectrum. And it's called the redshift. And the redshift is proof that things are moving away from us. You get the same thing with the sound. How many of you have heard the siren of an ambulance as it comes towards you? Woo, 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 woo. The sound drops. And the reason why the sound drops as the ambulance goes away is because the sound waves do what? Stretch. And as the ambulance moves away, the sound waves stretch, and that is evidence that the object is moving away from you. The same thing happens in light. The light from an object, when it moves away from you, also stretches, and that is evidence that the object is moving away from you. Well, this is something that he theorized in his theory, but Einstein said, no, just a theory. You're probably wrong. It wasn't until Edwin Hubble confirmed the visible proof through a telescope that Einstein changed his mind. Edwin Hubble was doing research on Mount Wilson's observatory and was measuring the distance of galaxies from Earth. And while he was doing the measurements, he saw that in every direction, galaxies were flying apart. They were moving outward. And the further a galaxy was away from our own, the faster it was moving outward. So the most distant galaxies were moving at incredible speeds outward and increasing in speed. In 1929, Hubble formulated the empirical redshift distance law of the galaxies, today simply known as Hubble's law. This was observable evidence that matched Einstein's theory of relativity, that we indeed live in an expanding universe. So Hubble called Einstein down and said, see for yourself. There's Einstein looking through Hubble's telescope. Well, in 1922, Albert Einstein had read Alexander Friedman's work and said, nope, not going to follow it. And then in 1927, he read Georges Lemaitre's work and said, nope, I'm not going to follow it. And then finally in 1931, he got his own eyeballs into the telescope of Hubble and saw for himself the redshift. That light was moving outward in all directions, and he couldn't deny it any longer. And not too long after that, Einstein changed his mind and called his cosmological constant the biggest blunder of his life. Today, scientists all over the globe are looking at the beginning of the universe and saying our universe must have started, but it started with something called the Big Bang. How many of you have ever heard of the Big Bang? Okay, that's everybody. Lawrence Krauss from Arizona State University, cosmologist there, travels all over the world, says how much of the evidence supports the Big Bang? All evidence supports the Big Bang. We're going to test his theory with observable evidence in just a moment. All evidence supports the Big Bang, so he says. Stephen Hawking, theoretical physicist, says almost everyone now believes that the universe and time itself had a beginning at the Big Bang. Now, before we accept the Big Bang, let's take a closer look at the theory and the evidence. First of all, scientists assume that if you go back in time, you eventually arrive at a place where all matter is condensed into one very tight ball. They call this ball the singularity. And you remember, they mentioned how big this singularity really was. What was the word I practiced over and over? Infinitesimally small, which means it can't quite be measured, but scientists have tried to measure it, or at least theorize the measurement. And they've said that that dot, that singularity, now remember, this is the entire universe in this small dot, is several billionths of the diameter of a proton. That's how small this dot was. So, Stephen Hawking went a step further, and off of Einstein's theory of the curvature of space says when you get that small, the curvature of space curves so tightly that it eventually curves that matter until it's gone. And this is what he says. He says that the curvature of space actually comes to the place where it gets infinitely tight and you eventually come to a 0 point. A point where time and matter and energy no longer exist because the curvature of space has gotten so tight. Alan Guth says this: the observable universe could have evolved from an infinitesimal region. It is then tempting to go one step further and speculate that the entire universe evolved literally from what? From nothing. John Barrow says that the singularity, that small point of the Big Bang, space and time came into existence literally from nothing. Nothing existed before the singularity. So if the universe originated at such a singularity, we would truly have a creation ex nihilo, or out of nothing. Now wait a minute. What current respectable physicists and cosmologists are saying is that our universe came from nothing. You see, friends, here's the grand problem. If you go back in time until the universe is one tight ball of matter, you haven't yet explained anything about where the universe came from. Where did the ball of matter come from? You keep going back saying, well, where did that come from? Well, where did that come from? There are only two options. Matter has to create matter, or matter has to come from nothing. This is a real problem for scientists who have a materialistic worldview. Where did matter and energy come from? Stephen Hawking tried to answer this question by saying, so where did the energy come from that created the matter? The answer, listen carefully, that it was borrowed from the gravitational energy of the universe. Now, what is Stephen Hawking trying to explain? Where the universe came from, right? And he's saying the way we can explain where the universe came from is we have to borrow energy from the universe to explain where the universe came from. What universe? If you're explaining a universe from the same universe, how do you get the universe? I mean, you just kind of go round and round, don't you? If you're creating the matter in the universe and you have to borrow energy from the universe in order for the universe to exist, how's that even possible? The universe does not exist until matter and energy exist. What then are you borrowing from? And so here's the dilemma that scientists are faced with. Now, I'd like to share with you 7 major problems with the Big Bang Theory. These aren't problems that I've found. They're problems that scientists all over the world are finding, and many of them are choosing to abandon the Big Bang Theory because of it. The first problem is that wherever you look in space, there is a uniform temperature. Uniform temperature in space requires longer than 13.8 billion years. In 2012, the WMAP data estimated the universe to be 13.772 billion years old. And that basically means from the moment that the Big Bang exploded until, all of the pieces arrived together here, right now, it's been 13.772 billion years. In 2012, Planck measured the age of the universe at 13.82. So it's about 13.8 billion years for the age of the universe. Now, the WMAP data also revealed that and this is a satellite that circles our globe, also reveals that the universe has a uniform temperature of 200 degrees microkelvin in all directions. The problem is that when the Big Bang explodes, you have all of this energy, all the energy in the universe that is exploding rapidly at one point in time. And all of that energy explodes outwards, and that energy has to be displaced throughout the universe. How long does it take for that energy to eventually be displaced throughout the universe so that the temperature of the universe becomes even? Well, there's not enough time for energy to disperse evenly in only 13.8 billion years. So the Big Bang cannot account for the even temperature in our universe. The second problem with the Big Bang is that the distribution of matter in our universe is not uniform. In other words, we'll go back to the Big Bang. This Big Bang should have matter spewing out in all directions evenly. For instance, if you take water, you pour water on your countertop, what does that water do? Spreads out evenly, right? And the same thing, if you pour cement, you watch it spread out evenly. This is what should be expected from the Big Bang. It explodes, everything spreads out evenly, but when we look in the universe, we don't see matter spread out evenly. Instead, matter is clumped together. We have matter clumped together in solar systems. We have matter clumped together in galaxies and in clusters. All matter is clumped together, and all matter is just spinning around in these clumps all over the universe, and it's not uniform. The third problem is that the universe spins at all. When you look at our universe and you think of the Big Bang exploding, an explosion sends everything out in straight lines, right? If you shoot a gun and the bullet is shot, is the bullet going to start orbiting you? No. The explosion projects that bullet in a straight line. And it's going to keep going in a straight line until it begins following the curve of space. Eventually, that bullet will lose energy and begin following the curve of space down. But that bullet is going to go in a straight line as it explodes outwards. And that's what should have happened. But when we look at our universe, we don't see things going in straight lines. Instead, wherever we look, things are going round and round and round and round. Planets are going round, solar systems going round, galaxies are going round, everything is spinning. And so scientists have said that the singularity itself must have been spinning. Like a merry-go-round, going round and round and round. But I want you to imagine children on this merry-go-round. And the merry-go-round is spinning, and it's spinning faster and faster. And pretty soon these children are holding on to the edge of the merry-go-round, and they're spinning faster and faster, and pretty soon one of those kids, whoo, goes flying off. What direction is that child going to be spinning? It's going to be spinning in the same direction as the merry-go-round. If the merry-go-round is going clockwise, every child that flies off that merry-go-round, and I've flown off a few, is going to spin. They're not going to go in a straight line. It's not like a potato launcher. You don't launch in one direction. You spin. You may start out head first, but you end up feet first into the gravel, right? You spin. And it's all going to spin in the same direction. So if the singularity that began to expand was spinning, we'd expect that everything that came off of it would be spinning what? In the same direction. There's a problem. The things in our universe don't spin the same direction. When we look through our telescopes and study the spinning objects of outer space, we discover that some galaxies are spinning backwards. Some planets are spinning backwards. Some moons are spinning backwards. This is called retrograde motion. Planets that spin backwards are Venus, Uranus, Pluto. Planets such as Jupiter, Saturn, Uranus, and Neptune all have moons that spin in both directions. Galaxy NGC 4622 is rotating backwards. And so, we come to point number 4 of the Big Bang, mature galaxy formation. And this one I'd like you to follow me in your mind. When we look at the edge of space through our telescopes, we're looking at things that it takes a long time for their light to travel from the very edge of space to where we are. Now, how fast does light travel? At the speed of light, right? So light's traveling at the speed of light, and it's coming along, and it's traveling, and it's traveling, and it's traveling, and it takes 13.8 billion light years for that light to get here. Now, if I'm standing here at 13.8 billion light years away, and suddenly I see light through a telescope, how old is that light? How long has that light been traveling? 13.8 billion years. And this is the key. When scientists look through their telescope at the very edge of space, they're looking backward in time. They're looking at light that existed 13.8 billion years ago. So at the edge of space, you should be seeing the gradual formation of stars, the gradual formation of galaxies, the gradual formation of clusters, which are galaxies all clustered together, until you come closer and closer to our own point in time where you see mature clusters, mature galaxies, mature stars, things that obviously have existed for a very long time. The strange thing is that when scientists have been looking at the edge of space, they've been discovering galaxies and clusters as mature as the galaxies and clusters that exist right in our own galactic neighborhood. This is what the Astrophysical Journal Letters says. 15 mature galaxies were found at a record-breaking average distance of 12 billion light years, when the universe was just 1.6 billion years old. Their existence at such an early time raises new questions about what forced them to grow up so quickly. Roberto Abraham said, "It's not quite time for theorists to panic, but we're getting there." In 2015, Caltech astronomers published a discovery of the oldest detectable galaxy. It's named EGS 8P7. It is more than 13.2 billion years old, when the universe is supposed to be 13.8 billion years old. How did an entire galaxy form in just 6 million years? You have to account for the formation of stars and planets And all of these things have to somehow come together and begin swirling together and form definite units. In 2016, they found another galaxy called GNZ11. It's a remarkably luminous or brilliant galaxy just 400 million years after the Big Bang. GNZ11 is remarkably and unexpectedly luminous for a galaxy at such an early time. Now, we talked a little bit about clusters, but they've also found mature clusters at the edge of the universe. And clusters are when galaxies come together and form these huge groups. Groups of galaxies are called clusters. I'm not even going to try and say this one's name. CL whatever is a cluster of galaxies that exists about 11 billion years away from us, or 3 billion years before the Big Bang. They found evidence suggesting that most of the galaxies in the cluster were not forming stars, but were composed of stars that were already 1 billion years old. This makes the cluster a mature object similar in mass to the Virgo galaxy cluster, which is the nearest rich galaxy cluster to the Milky Way. The Virgo galaxy contains 2,000 galaxies, and our own Milky Way is part of that. Thus, a cluster that exists at the edge of the universe is compared in complexity to our own cluster, the Virgo cluster. This should not be possible in a universe started in a Big Bang scenario. Number 6, the surface brightness of objects at the edge of space or distant galaxies is the same as close galaxies. This is what SciNews had to say about this. The scientists carefully compared the size and brightness of about 1,000 nearby and extremely distant galaxies. Contrary to the prediction of the Big Bang theory, they found that the surface brightness of the near and far galaxies are what? Identical. So in an expanding universe, the most distant galaxies should have hundreds of times dimmer surface brightness than similar nearby galaxies, making them actually undetectable by telescopes. But that's not what we see. What we see is that the brightness of galaxies at the edge of space and the brightness of galaxies right here match. Same surface brightness. Now this one you won't forget. The oldest star in the universe that they found is called the Methuselah star. You may forget everything else, but you aren't going to forget the Methuselah star. The Methuselah star is said to be about 16 billion years according to the initial calculations. They worked, and of course this caused immense problems. So they worked and worked and worked on it and was able scientifically to shave off some time and get it down to 14.5 billion years. But this is still almost 1 billion years older than the universe itself. So how do you have a Big Bang? Explain every star, every planet, every solar system when you have things in the universe that are older by almost 1 billion years than the very universe that was supposed to create it. What would you say about a child that was 1 billion years older than his mother? Probably not his mother, right? This star, 14.5 billion years. These 7 points and other points have led a large and growing group of scientists to write an open letter to the scientific community. And this is a portion of what their letter says. In cosmology today, doubt and dissent are not tolerated, and young scientists learn to remain silent if they have something negative to say about the standard Big Bang model. Those who doubt the Big Bang fear that saying so will cost them their funding. Even observations are now interpreted through this biased filter, judged right or wrong depending on whether or not they support the Big Bang. So discordant data on redshifts, Lithium and helium abundances and galaxy distribution, among other topics, are ignored or ridiculed. This reflects a growing dogmatic mindset that is alien to the spirit of free scientific inquiry. These scientists are calling on cosmologists and physicists and others throughout the world. Things have to change in the scientific community because what we're all observing is completely different from what science is saying. And they're saying this through letters, they're saying this through papers, and the scientific community, the echelon at the top, is trying to shut them up because we want our worldview. And it's a struggle for scientists. They struggle to hold on to the evidence and also hold on to their personal worldviews, views that see the universe as eternal. Robert Dickey from Princeton University said, "An infinitely old universe would relieve us of the necessity of understanding the origin of matter at any finite time in the past." Some scientists are abandoning the Big Bang Theory and are moving towards other theories. Here's 3 of the more popular theories that they're moving towards: the steady state theory, the oscillating universe theory, which basically says that our universe is expanding and then falling in on itself, and then expanding and falling in on itself, multiple Big Bangs over and over. And you have to do that so that you can have an eternal universe, right? Like an accordion. Or the multiple universe theory, saying that our universe was simply spawned by another universe that we haven't detected yet. All of these theories say that the universe is eternal. Is there evidence against an eternal universe? The second law of thermodynamics is one of those evidences against an eternal universe that pretty much puts away every theory that talks about an eternal universe. What does the second law of thermodynamics say? Well, it says that the universe, or anything that is in a closed system, like the universe, or when we shut the doors of this room, like this room, a closed system, is using up all of its usable energy gradually over time. It's like having a hot cup of coffee that you set out on your counter. And that cup of coffee, when you first set it out, is steaming away and maybe even bubbling. But you forget about it on the counter. And you go about your daily business, and later on that day, you come back to your coffee and you realize, oh man, I left the coffee out all day. And you go to take a sip of that coffee, and let me tell you, cold coffee is not something you want to drink. Well, I guess there's iced coffee, right? But where's all the energy gone? Where's all the heat from that coffee gone? It's gradually dissipated into the room until the room temperature and the temperature of that hot liquid equal 0. And at that point, energy from the coffee ceases to go out into the room. It becomes neutral. All usable energy has now been used up. And this theory says you can't go back the other direction. You can't now take the energy from the room and have it flow back into the coffee and heat the coffee up. Anybody ever had that happen? No? It only goes one direction. Basically, hot goes towards cold, but cold never goes towards hot. You can heat, heat travels in one direction. Things that are hot become colder, but things that are cool don't automatically become hot unless you put a heat source underneath them. So all the observable energy in a closed system is gradually being used up. Now think of the universe. The longer our universe exists, the more usable energy is turned to unusable energy. If our universe was eternal, how much usable energy would our universe have? 0. All of the stars will have burned out. Every source of heat would have gone out. There would no longer be any usable energy in our universe if our universe was eternal, according to the second law of thermodynamics. The second law of thermodynamics also says that order irreversibly moves towards chaos. And if you go to Cuba, you can see this. Buildings that were erected in the 1950s and haven't been touched for 50 years look a lot different than they did when they first were erected. Everything gradually breaks down. Brand new buildings today, 50 or 100 years from now, will have the paint peeling, the walls beginning to crumble apart. And this is according to the second law of thermodynamics, which says that everything of order is gradually, progressively, and irreversibly moving towards disorder. So if we lived in an eternal universe, there would be no observable order in our universe. Since we observe order in our universe, we can deduce that the universe is not eternal. It's moving towards disorder according to the second law of thermodynamics. If the Big Bang cosmological scenario is abandoned, the question of what will replace it is a major issue because a more viable, non-theistic contender does not now exist. All of the competing theories suffer from as many, if not more, problems than the Big Bang. Alexander Vilenkin from Stanford University says none of these scenarios can actually be past eternal. All the evidence, how much? All the evidence we have says that the universe had a beginning. If the universe had a beginning, it cannot be eternal, right? Because something that is eternal does not have a beginning or an end. So having a beginning is evidence that the universe is neither eternal nor divine. Thus, pantheism comes crashing down. And because the universe is not eternal, atheism also, as a worldview, comes crashing down. Theism, according to this model and according to the observable evidence in the universe, is the only worldview that fits the evidence of a universe that has a beginning, a universe that is not eternal. The universe had a finite beginning, a point at which matter did not exist, and then a point when it came into existence. Since the universe cannot create itself or cause its own existence, the cause of the universe must exist outside of the universe. Following? Which worldview is the only worldview that supports an eternal entity outside of the universe interacting with a finite universe? Theism is the only option. It's the only one left based on the evidence. H.J. Lipson says, I think, however, that we must go further than this and admit that the only accepted explanation is creation. I know that this is anathema to physicists, as it is to me, but we must not reject a theory that we do not like if the experimental evidence supports it. So let me review the evidence quickly with you once more. Number one, the universe is expanding, so has a beginning. Hubble observed the redshift of galaxies, everything moving outward. Einstein's equations fit it, the general theory of relativity. And then we looked at the second law of thermodynamics, which basically states that an eternal universe is not possible. Usable energy is being used up, and the universe is moving towards chaos. All of this shares with us that we live in a universe that is not eternal, a universe that had a beginning. And then we looked at evidence that the Big Bang was not the cause of the beginning of the universe. We looked at the uniform temperature of space, the non-uniform distribution of matter, the universe spinning both directions, mature galaxies and mature clusters that exist at the edge of the universe, the surface brightness of distant galaxies matching the surface brightness of galaxies that are nearby. And finally, the one thing you won't forget, the what? The Methuselah star. A star that is older than the universe itself. George Greenstein, an astronomer, says that the thought instantly arises that some supernatural agency, or rather agency with a capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Way back when, the astronomer Nicholas Copernicus had this to say: "The mechanism of the universe, wrought for us by a supremely good and orderly creator, the system, the best and most orderly artist of all, framed for our sake." Friends, scientists down through time have looked up into the stars. Many have gazed at these celestial bodies with questions running through their minds, and more than one has concluded that our universe declares the existence of a supreme being. The evidence has led many scientists to a belief in God. Nicholas Copernicus, Pascal, Halley, Kepler, Isaac Newton, Robert Boyle, Galileo, Alan Sandage, Sir Frederick Hoyle, Arno Penzias, Charles Towns, and many more. Edwin Hubble's student, Alan Sandage, remarked, "Here is evidence for what can only be described as a supernatural event. There is no way that this could have been predicted within the realm of physics as we know it." And Alan Sandage, an astronomer, had been a long-time agnostic, but because of the science has come to a belief in God. Anthony Flew, who you see on the screen, was the most, or has been touted as the most notorious atheist. He was a devout atheist, debating pastors, Christian apologists, religious personalities in front of large audiences about the existence of God. He felt he had solid reasons for why he did not believe God existed and why he had chosen atheism. Anthony Flew always said, "I will go wherever the evidence leads. If it leads to God, I'll go there. If it leads away from God, I'll go there. I'm going where the evidence leads." For years, this man stood against this notion that God exists, until recent discoveries in science began to plague the mind of the now aging atheist. The evidence was beginning to show that nothing short of supernatural powers could have brought about our current universe. The same battle, no doubt, raged within Anthony Flew's mind as had raged in Einstein's mind. Will I follow the evidence or hold on to my philosophy? And let me tell you, Anthony Flew had many reasons to hold on to his philosophy. He was respected in the scientific community. He had for years opposed the idea of God. His reputation was on the line. His whole life work had been built on the premise that God did not exist and the universe was eternal. But Anthony Flew had always lived by one principle, that he would go wherever the evidence led. And in 2004, he sent a shockwave throughout the scientific community when he announced he had come to a belief in God. He explained repeatedly that he had to go where the evidence led. He has since wrote a book, "There Is a God: How the Most Notorious Atheist Changed His Mind." Now, the most important question of the night: what will you do with the evidence? Will you dare to question? Will you dare to explore? Will you leave space for the existence of God?